Hi, everyone. We're still getting quite a few people on, so we'll wait another minute or two. But we do have a packed agenda, so we will get started on time once we have all of the necessary people.
Hello.
Hi, David. How are you?
I'm doing well. How are you?
Doing well.
Everyone looking forward to Thanksgiving?
Yes, at least I am. Looking for a couple
too.
days off sounds nice.
Yeah. Well, I've got a turkey to cook for about 10 people, so.
Oh, wow. So it's probably, did you already
guy.
find your turkey? Because I heard there was a turkey shortage.
Yeah, no, I got what they call a heritage bird. So the guy told me, he said it's the closest thing that you can get to a wild turkey that's still from a commercial
Interesting.
farm. So yeah, so I'm try that this year.
Awesome. I look forward to hearing how it is.
Are you traveling?
Well,
Kendall, are you staying home?
If you call just driving to Dallas, which is only 3 hours away traveling, then yes.
Okay.
But what about you? Are you staying home?
Yeah, we're hosting this year, so.
Okay, no, that's nice.
Yeah, well, so I have a bunch of family coming in. So. Yeah, I'm going to be a busy guy for the next week.
Yeah, no kidding.
Yeah,
I've got a Gantt chart set up for my preparing my Thanksgiving like a true program manager.
Love it. Suresh, were you trying to say something?
Yeah, Kendall, I have a logistic request because of this daylight time.
Yeah.
The meeting turned out to be very late for people who are joining from IST zone. So can you see the possibility of moving this meeting to an earlier slot by an hour?
How does everyone feel about
any other day also is fine.
How does everyone feel about that? Would we be interested in moving this meeting an hour earlier? So that would be, doing math here, 7:30 a.m. Pacific time?
That would be a little hard.
That'd be a little hard. It's kind of early for you.
Okay.
Maybe
8 a.m.
Would
somewhere in between, maybe 8 a.m.
8 a.m.
Would
Pacific.
Would 8 a.m. Pacific work for everyone? I'll take it to a poll and into the Slack, and we can decide there, so everyone can weigh in, especially the ones who maybe couldn't join today. Does that sound good, Suresh?
Yeah, perfect.
Okay, perfect. All right, then we will move to our first topic. We have David and Catherine joining to discuss the Magma adoption with ONAP. So I will let y'all take it away.
All right, thanks, Kendall. I'm not sure, is Catherine on?
No, Catherine won't be there.
Okay, all right, that's fine. So that's fine. So thanks, Kendall and Phil, for putting us on the agenda this week. It's been an ongoing topic in the ONAP Enterprise Task Force meeting, discussing how best ONAP and Magma can integrate. And we had some discussions about this and arrived at a point where Marshall and Jorge had some ideas about how this would work, and we needed to get that in front of the Magma team. So thanks for giving us the opportunity to meet with you. We did, the thought came up that it would be useful to have a kind of a preliminary meeting to sort of discuss the topic to be better prepared for this meeting. So we did that, I think that was Tuesday, and had a good discussion. So I'm going to go ahead and turn it over to Marshall and Jorge, and Marshall, maybe you can kind of lay out the problem statement for us, and also maybe just quickly review the discussion from a couple of days ago.
Yes, can you hear me?
Yes.
Okay, thank you. So the problem statement is the integration of Magma KPI into an app in order to be able to create control loop that will allow to better prepare to have this blueprint at the end, and support security and everything related to control loop with Magma through an app. So, like David said, we made some POC in order to see what we can do. We have prepared a small presentation to lay out what we have done until now and try to find the next step. So without further delaying stuff, I will let the floor to Jorge.
Okay, thanks, Marshall. Let me share my screen here. Can you see my screen?
Yes.
Yeah.
Okay. Great. So, okay. So my name is Jorge Hernandez. I work for AT&T on the ONAP project. And as part of the ONAP Enterprise Group, we are looking into ONAP control loops and their integration with Magma. So on this task, I'm working with Marshall and also with BJ Venkatesh Kumar, which are supporting this talk in the meeting for any questions. Okay, so let's get started. Okay, so just to give some context about the projects, basically this is the Magma project. This is where ONAP resides, and there is an interface between both projects. Okay, so ONAP will be used for network management and orchestration. So that's the context of the talk, and we are going to dig deeper into the control loop integration. So it's like a sub-project within ONAP. Okay, so we are going to talk a little bit about control loops in ONAP, Magma metrics, which are key in order to realize control loops, monitoring options that we explore when we started looking into Magma, a POC that we did, basically just to basically explore communication between ONAP and Magma for control loops. And specifically, we were looking at the metrics, getting metrics out of Magma and using them for a control loop implementation. Then we're going to be talking about, we're discussing about the VES, which is a format for event data, and it's something that we use heavily in the ONAP side. We're going to be asking for feedback in a few topics related to control loops. So this is a high-level slide for control loops. I'm not going to get into details, but basically you define a control loop statically at the same time. Then you deploy it, and it will become, so it will start basically monitoring and deploying any actions that it has to deploy according to the control loop specification. For So in the control loop, basically ONAP will be the network controller, and Magma will be the monitor element, the target. So that's, and we will implement actions defining the control loop against Magma in order to, for example, perform some recovery actions, whatever we decide the control loop to be. In the context of the POC, what we did is we just explored the monitoring interface, and we will get a little bit more into those details a little bit later. But in this diagram, this is the area that we were looking at, just monitoring, just getting alerts on some events that were interested from the Magma side. Okay, so this is when we were looking at the documentation for Magma, we found this picture very helpful. So basically, when we were working on the POC, we used the northbound interface in order to basically use the interfaces that Magma provides into the Prometheus infrastructure. So we were basically we created an alert receiver which is a webhook in order to send notifications, send alerts to ONAP, and we defined custom alerts that they were using that they were linked to the ONAP alert receiver, and all that goes into the Prometheus infrastructure, and that is being built upon in Magma. So we were exploring different options. We were leaning towards option one, but basically this option is programmatically create alerts in the orchestrator. Basically, we just created an ONAP receiver, which basically is going to receive the alerts that we programmed in Magma. So basically, we'll create an alert, for example, looking at CPU utilization or like a memory usage, for example, and then get those alerts pushed out from Magma into ONAP. So this is more like an asynchronous kind of interface where ONAP is just notified of what is interested in receiving. We consider, but we didn't look into a whole lot of detail into the metrics exporter that is in the documentation to consume metrics. I understand that this metrics exporter is currently used for the push gateway, the orchestrator cache push gateway, in order to basically collect metrics before they are given to Prometheus, the actual Prometheus systems. I understand from the documentation that there is the possibility to push out these metrics to other consumers. So that would be another possibility. The third possibility that we consider is on-demand polling of metrics through the REST APIs. So this is more like a synchronous kind of method of communication between ONAP and Magma. For different reasons, we decided to, at least for the POC, use the programmatic version, just getting notified of alerts on the ONAP system. Just to mention, maybe we can collect feedback from the team if it's something that we should consider. In the documentation there's the concept of events, and it's something that we didn't explore, but it will be another source of information that could be used from Magma. So the POC, basically, this is in an environment in Wind River, which is a lab that we use for different projects in ONUP. So basically, we had an installation. Basically, we had an existing ONUP installation. So we have it's a multi-node cluster, Kubernetes cluster running in Honolulu, the Honolulu version of ONUP. So this will be this area here. And then we had like a single VM where we are running the LTE gateway and also like the orchestrator. Basically, there is network communication between ONUP and Magma as they are connected to the same virtual network through, which is this one here. Yeah, Magma is running in 1.6, which I believe is the latest release version. Okay, so just digging a little bit more in the POC. Basically, we created an alert sync for pointing to ONUP. We choose the metrics of interest. In this case, we were looking at, for example, CPU utilization of the LTE gateway and also memory usage. So the alert sync will be on the ONUP side. Basically, this is where we are going to get notifications from Magma. Then we define, we created an alert REST receiver. This is based on the webhooks that you can define through the Swagger APIs. And we created the alert rule in order to basically link the CPU usage or memory usage to the REST receiver, and then then we saw like the alerts going into the ONUP system where as we wanted to go. Just for proof that, I mean, there's communication that can be established between the two systems, and we can receive alerts. Okay, for the sake of time, I don't think I have time to go into that, so I think I'm going to skip showing anything in the lab. So I'm going to move on into the next slide. Okay, so VES is a virtual event stream common data model. Basically, this has it has a specific format. It's defined in JSON. The best thing to look is a picture of what it looks like, and this is one of the examples in the source code base using for test. So there's a common event header section, and there's particular information about an alarm. So this format is adapted under the 3GPP standards and is used currently in ORAN and ONUP interfaces. And it was initially contributed under the OPNFB project by AT&T before it was adapted in ONUP. The reason that this comes into the picture, it will become more clear in the next slide. Okay, there are some references here in the slide, but let's go into the feedback. As I mentioned, like the VES format is something because of the heavily used in ONUP and perhaps and maybe integration with ORAN as well. This is one item that we wanted to bring to the attention of the Magma team if it's something feasible to support VES format in the communication with between ONUP and Magma. Okay. Other items for feedback is well, obviously for control loop we need to define a use case, and that's something that we are lacking right now. I mean, we're exploring ways to interface between the two systems, but we need to find like a use case that really can benefit Magma and can use ONAP in order to make to provide some enhanced functionality over Magma. So this is one of the items that we have to do as a group. We need to define a control loop use case that is applicable to Magma. Then once the control loop is defined, we need to figure out the right interfaces. Right now, we work on a prototype, and we need to still explore like actions to be performed on Magma. What kind of action we will be able to perform, as well as the interfaces, security between the interfaces, and so on. So these are items that will come after we define the a control loop. And another item that is related to that is the data that is to be monitored. Of course, I mean, there can be like a multiple flavors of control loop, and only a subset of data is of interest. So we need to define that as well. But all that falls under the same item, which is defining a good use case that can benefit Magma. And that's an area where we need feedback. Again, the second item is related to BES, if it's possible to support BES. One question to the Magma team is like, there are other capabilities that we should be considered. Right now, we are going through the northbound interfaces through the orchestrator. Should we consider, for example, events as well, or other ideas that you may have? Another item for feedback is other initiatives that we should be aware of, so there's no overlapping between our project and some other projects. So with that, I'm going to open it for discussion. And I think we have a good group of ONAP folks to provide feedback on that as well. Any questions about the presentation?
Anyone?
You're very clear.
Yeah,
Okay.
otherwise I'll give it. Yeah, can you hear? Yep.
Yeah. It's a really nice presentation. If there are no questions, I think we can move on to the demo. We have the demo, right?
Yeah, I wasn't planning on the demo. I was thinking like maybe there was more. I wanted to leave room for discussion, but I mean I can show. So I didn't prepare for the demo, but I have the windows there. Maybe I can show it. What I have. Let me check here. Let me see. Well, I have the windows ready. So yeah, the demo. I mean, it's just. Let me see here.
I can, yeah, regarding your last slide, any other initiative? There is one initiative going on regarding merger of like Hyperledger and Magma. So because Hyperledger and ONAP has already done few things regarding the API stuff. So this thing is also going on. Yeah, now you can move on to the demo.
Okay, so the Hyperledger, so that would be for, this is blockchain, right? It's a blockchain project.
Correct. So we will be storing some, yes. Yeah, we'll be storing some of the very important things that will come out of the Magma, the data that we'll be generating on the Hyperledger blockchain. Yeah, that's the goal.
Okay. All right, so that's something that we should be aware of. Okay.
Yeah.
Do you think that there will be any communication that we may need between through the blockchain, through the Hyperledger?
No, so Magma will generate. Magma is the source. So Magma will generate, let's say, some data for some users, something like that. So this is still work in progress. So similarly, like here, what you are doing, you are getting the alerts, right? You are taking alerts from Magma and getting it on the ONAP panel. So similarly will happen with Hyperledger, but what data will be taking in, that's not finalized.
And you will
Right,
do some specific development to integrate with Hyperledger, or Hyperledger will just leverage the existing Magma API?
So right now our goal is to use the existing Magma API. So we are in talks with the Hyperledger community. So they will guide us through that, like Hyperledger Telecom SIG, they will guide us. So after this call, we have another call like for with the Hyperledger or Magma integration. But yeah, this is still an early stage. So as we made progress, I'll let you guys know.
Okay, that's good to know. Okay, yeah. So again, for the demo, I didn't prepare that much, but I'll show you what I have here. Basically, this is a local system. There's like a couple of receivers. Okay, the one of interest could be this one. This is pointing to the ONAP cluster. So this is a node port that we exported there. And this is just like a dummy service where we're just listening for alerts. We're not doing anything with it. Just proving the point that we can receive alerts from Magma. Okay, that's the server interface. Yeah, so you see here, I mean, just going through the alerts, you see, like, I mean, there are CPU alerts and also memory alerts just being produced in the Magma system. Okay, so right now this is the CPU usage webhook. I mean, there are alerts coming up once in a while here. So we may get some of them as we are in this demo. So here I have so in the same VM again, I have this ID. I have the Magma account here, where it's running like an LTE gateway. And you see here it's passing the checks in order. Basically, was registered already with the orchestrator. Okay, and in the same machine here, let's say if I do a kubectl get paths 8R, and so you see like all the orchestrator, and again they're running the same machine here. Yeah. Okay. So I'm just exploring the Swagger API here. Okay, so there, let's go there. And if I do a look at the alert receivers here,
We are doing CPU alert or RAM alert?
I have one for each. The CPU alert. This is the I have the sync just collecting the alerts is running on the same host as the Magma as the LTE gateway and orchestrator. So this just goes to the local host. So this was the initial attempt. Then later on, we for the memory one, it was configured to send to the ONAP side, and that would be this one here. So that would be for the ONAP alert. So let me do it here.
Right. And we have orchestrator and access gateway deployed in a one VM in OpenStack environment where it can talk to other ONAP instances.
Yeah, exactly. Yeah. So if I do IPA, and if I look for Ethernet, let me look for ETH0. Well, let me look for the Ethernet interfaces here. So I'm looking for Ethernet 0. So you have Ethernet 0 and Ethernet 1. So this is under the Ubuntu account. Here, if I run the same command, yeah, let's go up. So you see here is the same IP. Right. So these are the two interfaces. This is the interface actually that hooks to the ONUP network through Ethernet 1. So here in this window, I have ONUP running. Let me look at. There's a bunch of components running in ONUP, even more than in the orchestrator. So let me. So I'm just looking, for example, for the DCAE, which is the analytics engine. Yeah. So I'm just looking at the DCAE paths in this case. You see here I added like this dummy Magma listener is running still under the ONUP namespace. And this is the one that is listening for alerts coming from Magma. Let me, if I do a logs here on that pad here, so you see, like, I mean, we are receiving alerts regarding the memory usage. So, so you see here, basically they can be correlated to you see the orchestrator here. This is the memory availability here. So basically this is the alert that we are getting. They use memory 10%, which which is this alert here. This is again through the Solar APIs. So this is the CPU % alert. Okay, they use memory 10%, which is this one. Of course, like, I mean, the boundaries here, like the 10% is kind of a silly number, but the point here is just to prove like communication and alerts can be sent from Magma to ONUP. So this is the one. So yeah, I don't think I have much more unless you guys have specific questions about it to show here.
Yeah. Any questions, anyone?
Hi, George. Hey, George. Just a basic question. I don't work on the ONAP layer. So from AT&T point of view, this is an interface, this ONAP automation, right, is an interface to monetize Magma-based network, right, using BSS and OSS kind of software, right, at a very high level.
No.
Yeah, go ahead, Marshall.
Well, no, actually here we were just really wanted to explore Magma itself before deciding what we can do with it. But we have no plan at this stage for OSS BSS management or whatsoever.
Okay.
Yeah, just to make clear, I'm here representing ONUP in this case. Yeah, not AT&T. So yeah, as you see, ONUP here is right. It's another project under the Linux Foundation here.
Yeah.
And it's just related to the management and orchestration of network functions. Actually, this slide is coming from the ONAP side.
Yeah, this is really in the context of the 5G Super Blueprint LF initiative. So it's nothing AT&T specific.
Okay. Yeah, thanks.
Yeah, you're welcome.
Thank you. So Phil,
in fact,
sorry, go ahead.
Yeah, so we wanted really to have from the Magma team some feedback about pointer of alert, type of alert, and use case, control use case for service assurance, for instance, that we have missed and that are important and key for the runtime of Magma. So I would have liked to have some information or pointer regarding that, if possible.
So Phil and Kendall, I'm wondering, so this is the basis for our proposal for integrating with Magma. So I'm wondering if it would be possible to task the Magma TSC with coming back with a response to what Marshall and Jorge have presented.
Yes, basically the slide Jorge is displaying here, the feedbacks needed.
So we can certainly take it to them for feedback. I don't think we necessarily need a formal response from the TSC on this. It's more just a sense of the community to make sure that we're on the right track. So we could also get that feedback from anyone who wanted to pass comments on from here. Could you send over to Kendall a final version of this deck, and then we can get it posted for people to take a look at, or you can post it in the Slack to review offline and see if there's any feedback, and we can certainly ask the TSC their opinion as well.
Yeah, that
Also,
sounds good. I'll do that. Yep.
Yeah. Also, one suggestion is there. We can create a ONAP channel inside our Magma Slack channel. Some project owner, something like that. There we can do all the discussions and interested team members can join in.
Yeah, I think that's probably really appropriate. Thanks.
Mm-hmm.
Really, as such, I have a question in this context. Already, there is some complementary infrastructure and applications already available within Magma. Say, the monitoring part, and then control loop as such is not fully evolved. However, a Kubernetes-based control part, I mean, say, for example, a desired state is getting deviated and spawning an instance kind of things are also planned as such. So I think ONAP is trying to solve the equivalent of that in the first bullet here.
So Suresh, put in context though, the things that you're describing are very Magma specific for doing those functions within Magma, and those become inputs or feeds or control points for a orchestrator that might be running a much larger overall system, including other elements besides Magma, and that larger orchestration function is what Magma is trying to solve for, where Magma is a component of a larger network.
Exactly.
Yeah, Suresh, I also think that, like Phil mentioned, right? So what we have, we can consider it as a domain orchestrator to an extent, right? But this one is the master orchestrator, which is going to kind of manage multiple domain orchestrators, including not only Magma, which is a core network, but also RAN, transport, and many other things, right?
Right.
So we need to see how, based on these questions, what are all the different events or triggers, I'll use a generic word, that we can provide that would allow ONAP to do the lifecycle management, orchestration, and all those aspects of the closed loop control, right? So that's the point under discussion right now.
Yeah. Got it,
Right.
Kader.
In the interest of time, and we do have a few more items on the agenda, or is there anything else on this that we wanted to cover off on?
So just to summarize, I heard a few actions. So Jorge is going to provide a final version of the deck for posting on the Magma site for feedback. And then we talked about setting up a Slack channel within the Magma Slack for ONAP discussions. Is that an action for you, Kendall? Or who manages the Magma Slack?
Yes, that would be me.
Okay, all right. And then do we need to plan for a follow-up discussion or any other follow-up actions maybe after the new year? Maybe we could follow up with a meeting in the Enterprise Task Force, or what do you think, Phil?
Well, let's see what kind of comments we get, and then we can build the follow-up from there.
Okay, all right. Okay, thank you again for giving us an opportunity to talk today.
David, this is Kader. Would it be also possible, what type of control loop actions that you would like to take, right, from the top-down point of view, right? Yeah, the questions are here is more like from bottoms up, based on what Magma supports, what kind of actions that we can take. But we can also look at from the top down, what kind of a control loop actions that ONAP supports today for other domain controllers. And we can work backwards from there as well. Just a thought. Is that a data that's possible to get access to? Or very basic minimum ones?
There are some use cases that we support in.
Yeah, go ahead, Jorge.
Yeah, I'll let you. Yeah, I was just going to mention that. I mean, we are. Right, and there are some use cases that we support on the ONAP side. Maybe that would be a reference just to get a feel of what you can do with Magma. With ONAP. But go ahead, Marshall.
Yeah, I just want to say, yeah, we don't have really ONAP yet. A standard set of actions for control loop. Because it's, I mean, we are not yet there. So I understand your question, but you won't have that much, except the basic use case that Jorge is alluding to. So here we wanted really to see from the basic behavior of Magma, if there are some really specific actions that are really specific to Magma that we should use.
Okay, so let's
understand. Hello, everybody. Yeah, Kader, this is Parthiban here. So I see that for this control loop from the Magma side, to start with, we could do something on the failure part of it. One such example can be like if the access gateway connection to the orchestrator is down, then that can be, I'm just citing an example. There can be some retries from the control loop that can happen. If at all there is coordinate changes like IP getting changed, then nothing can be done over there. But these are just an example. Yeah,
there's a kind of action and that you're looking for.
Yeah, so such kind of failure things can be taken out as a first step of control loop thing. I don't think with the OneApp's integration with Magma right now, there is a support for lifecycle management. That's going to be a separate topic for itself, I believe. If at all that is there, then that's going to be of very helpful because of upgrades coming in a shorter life cycle. That's a different thing to discuss as well, and that will be an interesting area to work on.
Yeah, agreed. Okay, we'll take this offline in the Slack, like Phil mentioned. It's a good input. Thanks, Javius, for clarification.
You're welcome. For the Slack, can you put somewhere the link to the Slack channel?
Yep. I will put it in there now. There you go.
Thanks.
All right, we only have 15 minutes left, so we'll move rather quickly. We may not be able to get to all of our normal updates, but I believe that should be fine. So if we don't get to your update, if you can just put it in the relevant Slack channels, that would be great. So next we'll have Lindsay going over the Magma roadmap preview.
Hey guys, can you see my screen?
Yep.
Okay. So I'll quickly introduce myself. We'll go relatively quickly because I'm going to actually be posting this and it will be available for everybody to review, and we can take questions even in the next meeting. But I just wanted to set some context. So I'm Lindsay. I'm the product manager for Magma at Meta, or Facebook, as most know of it. And so historically, we've kind of driven a lot of the roadmap, but as we are now part of the community, we are just one of those contributors, and you will see how that comes through in the roadmap. So right now we have a pretty good understanding of the contributions that are slated to come in. But over time, as contributors increase, we won't be that central source of information. And so this should ultimately be driven by the foundation. But right now, to give some people clarity on what's coming down the road, we thought it could be good to post something like this. So here's just our mission from why we work on Magma from Meta perspective. And so I'm going to skip a bunch of slides here and focus on, so quickly here, we will be posting some guidelines on if we mark a feature as alpha, beta, or GA, what that actually means. I think most people are kind of aware of the different phases, but we want to make sure everyone is aligned on what the maturity of the feature given the different stage. So this was stuff that landed in 1.6, and it was like a lot of improvements in scalability and on the Access Gateway, Orchestrator, and NMS, and a lot of cloud work. But I want to actually go to features that are in flight. And this is where you can really start to see that Meta is not the only person contributing to the features for Magma. And we have slated here some other contributors from the ecosystem. And obviously the idea is that this will grow over time, but here are some things that you can expect to see in the next release. And I have here forecasted for Q1. The exact timeline will be determined, but these are some things that will be coming in the future. So just wanted to share that. Like I said, I will be posting this deck onto GitHub and the Magma Core website. And the hope is that we will have either me or for the short term or somebody that will keep this updated over like maybe at least on a quarterly basis. But if we see some big changes, maybe on a monthly basis. I just wanted to share theirs here. I will quickly open it up if there's any quick questions on this. Like I said, maybe if there's like once you guys are able to access this information and kind of go through it, we can then take questions in the Slack channel or even in the next meeting, but I will just leave it here for a quick few minutes to see if anybody has any comments or questions.
Just a quick question on these features in flight. So release 1.7, it doesn't appear to address the 5G oriented activities. Is that correct?
Sorry, I should keep going. So this is LTE. There's actually a specific 5G slide. So this is it's laid out a little differently, and these contributions are really coming from the Wave Labs team, so we can get them to maybe get it more on a release cadence rather than like H1, H2. But we don't have like the insight into exactly what is coming in which release. But if you are looking for something specific that you thought was coming in 1.7, you can mention it here, or we can talk about it more on Slack.
Yeah. Thanks, Lindsay. This is Kader. I'm not sure who asked the question. I wasn't able to see it. The specific to the releases, we presented in our last Magma 5G meeting. There's a recording there. I also encourage those who wants to get more updates on 5G. We have a monthly Magma 5G meeting that happens on second week, Friday, 10 a.m. CST. It's in the calendar. Feel free to join if you want to get more updates about 5G there. Thanks, Lindsay. Just want to jump in and share that.
Thank you. Appreciate it. Okay, so like I said, I'll post this. I will get the link shared to everybody, and then keep asking questions. We can do it on Slack. We can do it in the next meeting. Most of the folks who have the good answers are going to be on this call anyways and can give you more insight. So we'll just leave it there.
Great, thanks, Lindsay.
No problem.
All right, moving to Suresh with a 5G update.
Yeah, sure, Kendall. Let me share my screen. We have so much to update today because in the previous meeting also we didn't join because we have holiday in India. Can you see my screen?
Yep.
I give a brief update on some of the features that are under development or they finished integration test and are available now for community to try out. However, some of these slides will go with a little overviews. The basic procedures related hardening exercise is ongoing. Yogesh, you want to quickly go over the slides? Yogesh, are you available? Okay. Otherwise, I'll talk through. So, as part of the hardening exercise, we have added unit tests on access side of the code in 5G. Initially, last quarter, we didn't have even 30% coverage. Now, we are close to 60% unit test coverage to improve stability of 5G code base. I'm sorry. And on the multi-session support, the goal for us in Q4 is to support 4 sessions per UE. So we have 2 known bugs on that. And the gateway.mconfig has got all the AGW related configurations. And we have made some improvements on the way we are configuring AMF. And scale test is going through some stability related issues. Currently, even though we have a goal of stabilizing the AGW up to 600 UE registrations that are connected to 12 GNBs. As of now, the AGW is stable only up to 200 UEs that are connected to 12 GNBs. Currently, there are 5 open issues. Largely, they are crashes. So it's a few more weeks for us to go to stabilize for the scaling numbers. Currently, the uplink downlink aggregate throughput stands at 400 Mbps for 200 UEs. So that is the scaling status we have. The stateless feature is going through design right now. There is a prerequisite for stateless feature to be adopted on the access side of 5GSA. The data structures that are there on the access side need to be refactored. The refactoring is kind of complete. now the design is in progress. Basically, the data is persisted in Redis DB. And to persist in Redis DB, what we need is we need to invoke the gRPC interface calls. So that's for that reason, the data structures are little getting aligned towards the protobuf syntax. So this is an ongoing exercise in the month of November. And negative scenarios related to the procedures we had been implementing last quarter and this quarter as well. The 5GMM causes, a good number of them were implemented last quarter. However, in this quarter, we have added a couple of them more. And the basic 5G SM causes are supported as part of these PRs. And these PRs are now merged on master. So that's on the SUPI registration support. SUPI registration support code and unit test is complete. Basically, there is impact on access side and also on the subscriber DB and also on the orchestrator. These PRs are in review right now. That's the SUPI registration support we are implementing in 5GSA. And 5G QoS, the static QoS support is already in place. However, there are few bugs. There are 3 known bugs, in fact. And to support dynamic QoS, flow identifier related changes are to be implemented. In OVS, the flow implementation is in progress. In first half of 2022, the rate limiting and then the flow identifiers will be slice specific, because right now we are implementing basic network slicing support in Q4 21 and also in January 2022. And we also have made changes on 5GSA related to usage reporting and charging. Currently, code is in review. The plan is to make this feature available in Q4 2021 itself. In the interest of time, I'm going a little faster. If anyone has any questions, we can discuss offline. IPv6 support is also in progress. Basically, through this feature, UE can get IPv6 address, and dual stack support also is getting added. As such, the code changes in OVS are already available on master. Pipeline D related changes are in review. SMF, AMF related changes. Design is complete, coding is in progress. In Q4, this feature also will be available. And network initiated session modification that is going through coding phase, and dynamic policy support through N7 interface via FEG relay is also in progress. And network slicing support, here is a list of tasks that are going to be implemented in the month of December and January on the orchestrator, AJW, and also on the NMS. And also team are working to get TPOC and badging for the Magma implementation. Here is the test status. In SIT, we were able to browse internet through CPE. However, subsequently, we landed in issues on the PD session establishment. We asked for support from brand vendor. And the scale test, even though it is not stable for 200 UEs, when GUI-based registrations is tried, when SUSI is tried as the mobile identifier for 600 UEs, the benchmarking is tried a few times, and the memory utilization at AJW level in the bare metal deployment memory utilization is fairly stable. So in the interest of time, I pause here. Back to you, Kendall. We are just on top of the hour.
Yes, we are at time. So we didn't get to the release update and the DevOps update. So if y'all don't mind posting any updates in Slack, and then we can reconvene after Thanksgiving, so in 2 weeks. But for now, I'll let you all go. Have a great day and enjoy your weekend.
Thank you.
Thanks, Kendall. Thank you all.
Thanks. Thank you, everyone.
Thank you.
Thank you. Bye.